LeetCode problem number 2013, detect squares. So this problem gives us a stream of points on the XY plane. So it's a graph, and we have to design an algorithm. So that's the goal, that adds new point from the stream into a data structure. So it's up to us whether or not we want to use a list or a map. Duplicate points are allowed and should be treated as different points. So this is another important point that we need to point down, write down. And given a query point, we have to count the number of ways to choose 3 points from the data structure such that the 3 points and the query point form a axis line, basically a square, right? So a good example, let's say we are given these 3 points here, right? Let me get out my. So let's say we are given these 3 points here, and this is the query, right? So based on the previous points that we have stored, we want to find out whether or not this will form a square. If we query something that does not make a square, right, then this is not considered a square. So if this is not, and this is considered a square, right, and this is considered a square as well, right? So only squares, there's no rectangles, right? So 4 sides have to be the same length. So based on this hint, we got not really a hint, but this observation of it being a square, we can actually just, let's say from the query point, right? So what we want to do is basically, let's say we have, let's say this is 0, 0, x and y, this should be 1, 0, this should be 0, 1, and 1, 1, right? So let's say we have these points, and these points are stored in our data structure, right? And this is what we were given, correct? So we just need to find out the diagonal point, which in this case is 0, 0, right? So based on the way we determine whether or not it's diagonal is we use the x, we minus the y, we use the query x minus the diagonal x, and the query y minus the diagonal y. And by right, this should give us the height and width of the 2 points. If they match, right, if they are the same, it means that it's a perfect diagonal, right? It means that it's a perfect diagonal with the same length for height and width, right? By using this x minus this x, this y minus this y, we will get the height and length. And if they are the same, means that it's a diagonal. Okay, so step 2, this should be x, y, 0, and 1, 1, 0, 0, 0. Okay, step 2 is we just need to use, so we have this, right? So we just need to find out whether or not these points exist, right? These 2 points exist, right? These 2 points exist. And the way we can find it out is just by using, let's say this is the diagonal, so dx, and this is query y. And for this one, it will be query x and diagonal y, right? So we just need to query this from our, let's say I'm using a hash map here, and if they exist, they will be 1, and of course this exists, so it will be 1 as well. So this times 1 times 1 will give us 1. So the reason why we want to use a hash map as well is for this point, right? So over here it says that duplicate points are allowed and should be treated as different points. So coming back to the question, let's say we have 2 of these, 1 of this and 1 of this, right? So it will be 2 times 1 times 1, and it will get 2 squares, right? So we get 2 squares in total. And that's about it. So let's take a look at the code. So first of all, I initialize a map here. It's just a standard map with the key being the point and the value being the frequency of such points, right? So to add a point is as simple as just adding the point and incrementing it by 1. Okay, that's it. So in my count function, so remember that this point here is the query point, right? Let me bring up my pencil again. So this point here is basically this point, right? The query x and query y. But for this function, I'll be referencing them as just x and y's, right? So instead of qx, qy, they will just be x and y. So the next step I do is I have a for loop iterating through every point in my map, right? This is because, like I mentioned, I want to find out the direct. Basically, I want to check whether or not this point is a direct opposite, right, or a direct diagonal point. I forgot what I call it, but basically it's the opposite side of the point, right, for each point. Because there could be a point here, there could be a point here, and I don't know, there could be another point here that could make a different circle. So we have to treat each point equally and iterate them all together. So here I have a post. I basically open up. So this, remember, is the point. So post basically short term for position. So this is the position of the point I'm looking at. So here we have the if statement. This is the gatekeeper, right? So this absolute position first minus x not equals to position second minus y is basically doing the xy minus the px and py, right? So remember I mentioned if x minus px, we will get the height, right, or the width, right? Either one. And if both of them do not equal to each other, it is not a square, right? Because if you look at this example, for example, you can see that the height of this is shorter than the length of this, right? If this were to be the point. So this will make a rectangle, and we don't want rectangles, we only want squares. So that's what this thing is checking for. And this is basically checking if the point that we are iterating at is on the same x level, or same y level, or same x level as the point we're querying. Because if they are the same, we for sure know that it's not a diagonal, because to be a diagonal you have to, like I mentioned, they have not to be the same, right? So that's what this is for. Alright, so after that is done, so here is the part where I talked about the result. So I'm just gonna query the position first and second times the first y, right? Remember that, let's say this is 1 1, this is 0 1, this is query x, query y, this is data structure x dy, and to get this is basically this should be xy. So this is dx and query y, right? In this case will be 0 and 1. So here opposite, it will be qx and dy. Probably shouldn't have used q and d because they look oddly similar, but you get my point, right? So we're basically trying to find these values inside of our hash map. Okay, once we've done that, we multiply all of them, we multiply all the entries. So let's say all of them are present, it'll be 1 times 1 times 1, which will give us 1. This will just increment result by 1. If one of them is not present, right, let's say this doesn't exist, and we get only this, right, this is not a square. So anything times with 0 will give us 0. If, for example, this point, however, gives us 2, right, there's duplicate points as mentioned above. So each point is treated as a different point, like as mentioned over here. Duplicate points are allowed and should be treated as different points. So what will happen is it will be, instead of 0, it will be 2 times 1 times 1, which in this case would give us 2, right? If let's say this point has 2 as well, then it will be 2 times 2 times 1, which will give us 4, right? Which makes sense because we have two different points for two different, we have two duplicate points for two different points, and 2 times 2 will be get us 4. So after that, after iterating through the points in the map, I will just return the result, and basically that's it, right, for this function. So overall, this problem is a bit tricky if you don't know the trick to it, right? For instance, looking at the diagonal point as well as using a hash map. Other than that, it's pretty simple once you have known how to get around that. Anyways, that's all I have to show. Thanks.